Hey everybody. Wonder how many people are out there now. I'm just going to give you guys a few more minutes and to see who's logs on here. Okay, now I see people are starting to come in here. Hey Robert, how you doing, man? Rick, how you doing? Just waiting for the other people to give them a little bit of time to sign in here. So how you guys been, man, during these times? Well, I'll tell you what. It's not looking good. It's not looking good. It's kind of funny how all this stuff, one thing after another, you know. First the virus and then this with the demonstrations, man. But we got to make it through this one too. Hey Fred, how you doing, buddy? All right. Well, let me see. Okay, here comes some more. Let me just. Hey Rose, how you doing? Josh, Fred. Yeah, so there's a couple things I was going to talk about tonight. I just want to give the rest of the people a couple more minutes. There's some new people. I know that, you know, they didn't really know how, or I had to explain to them how to find me here. And we'll give them a few minutes, and we're just sitting here talking. And some of the things I was thinking about covering tonight was, one thing was searching. For some reason, a lot of people have problems with searching for certain things. But we're going to cover some of that. I was also going to go in and talk about Grbl Settings and what they do, why they're there, and how we can tweak them. And well, anyways, I'm gonna get started here. I hope everybody's doing okay, and hope everybody's safe from the virus and everything. I mean, we live out in the country, so out here it's no difference for us except we don't go out. Basically, that's about it. All right, let me turn you around here. There we go. Okay. And most people recognize Easel, but I'm going to go out of here right now and close all this stuff. All right. One of the things, like I said, I was going to talk about was Grbl Settings. All right. Now, Grbl Settings, on most machines, you know, smaller machines like this one here, the 3018 or the 6550 laser unit, it uses a set of instructions in the board, on the board itself. The Grbl settings, they are written into the EEPROM on the main board of the machine. They're the instructions. Here's just a list of all the instructions from $0, $0, 1, 2, 3, 4. It goes all the way up, and it goes up. Well, this one goes up to 132. I have this version here is a little bit older, so I am missing $30, 31, and 32, which I've written in there. But I know what they are, so I can tell you what they are anyways. Now, just a second here. There. Okay. Now, for example, when I talk about things, and if you're wondering, oh damn, Sorry, just dropped jizz. All right, as I was saying, when I talk about things, or there's things that come up, you know, in conversations, and people wondering, you know, well, what is that, or what, you know. So let's just take GRBL settings. Now, I go in here and I can go to Google and I can search GRBL settings. Now, here it says, comes right up here. I write in GRBL settings. Here it comes up, GRBL settings, doc to PDF search. GRBL settings, how to change GRBL settings, Arduino plotter GRBL settings. Okay, now let's just try, let me see if the first one here, see what that one. Usually, a lot of times, the first one is usually it. But if not, let me see, GRBL. Now see, here you have GRBL settings with a shapeco. DIY machine GRBL settings pocket guide. How to install, use GRBL with your CNC machine. GRBL settings calculator. Now, this one here is for calculating your stepper motors. Okay? Now, let me pull one up here. GBR settings guide. See what that says. Click here and it says, oh, here's another one. GRBL settings 101. A how-to guide. Okay? Now, here you have a universal code sender. If you want to use something like this, you can download. But I'm trying to find, actually, is the set of instructions which I have. Let me see here. Just one second. One second here. Okay, let me see here. GRBL dot. Oh, gotta hate when I. Let me see. Here we go. Now, GRBL.com. Let's see what comes up there. All right, now nothing came up on that. I'm trying to find the same list that I have myself, because it's a really good set of. Let me see if it's this one here. Let me see if this one is it. GRBL settings here. Let's see. All right, well, let's see this GRBL settings pocket guide. This is a good one. This one here basically tells you what each one does, okay? And it doesn't go into depth. Now, this was at GRBL settings pocket guide, okay? Revision B. Now, like I said, people ask, what do GRBL settings do? They control every part of your machine. Everything. They control, for example, your machine has to know how many pulses to send to the stepper motor to make your axis move 1 millimeter, for example. Hi, Sandy. Hey, David. Madalena. Glad you guys could make it. And we're talking about Grbl Settings. And I'm gonna look this now. This is what I'm talking about. This is like 20 pages or so, okay? And it uses basically like a half a page. There you see $0, and it talks all about it. It uses a quarter of a page for one, $1, the next one, step, idle, delay. Now, what I'm getting at with these numbers and with these instructions is that these tell your machine exactly how it's supposed to operate. For example, let me just give you a good example why I had to learn these. Okay? To make it real quick, when I assembled my machine, like everybody assembles their machine and everything, when I assembled mine, first of all, my x-axis, left and right, was actually right and left. So it was reversed. That was one problem. The second problem I had was my z-axis was only moving 1/5 of my desired movement. If I told it to move 10 millimeters, it moved 2. So that is how you fix all these things, and you can actually learn to tweak your machine with the Grbl settings. So the first thing I had to do when I had my machine and I assembled it and I tried it and I found out that the X was going in the wrong direction. Okay, so then I had to download this whole pack of papers so I could learn Grbl settings so I could repair my machine. Now, if you look on here where it says the second one up here, $2 and $3. Step port invert mask and $3 direction port invert mask. Now, $2 and $3, they have to do with direction of your stepper motor. Okay, so then I'm just going to go in here and get it here so I can bring it up and show it to you. And now here it says, for example, $2 step port invert mask binary. This setting inverts the step pulse signal. By default, a step signal starts at normal low and goes high upon a step pulse event. Okay, now I go right through. I could read all that, but I'm not going to waste your time. What I'm looking for is right here. Now this is the good part about it. Okay. Now, remember I said my Y and my Z, they were going in the correct direction. Okay? So I do not want to invert my Y and I do not want to invert my Z. I just want to invert my X. So I will look for yes, no, no. And right here, second one. Yes, I want to invert my X and not my Y or not my Z. So forget the mask. It's actually just a binary number, which is 1. This is a binary number of 2. And it shows it to you right here. Here's 1, 2, 3 is 2 plus 1, and 4, and then 5 is 4 plus 1. That's binary, okay? But, so, setting value is 1. So if on my machine, that's all I had to do was okay. So on my machine, what I had to do was change my value to 1. So I wrote $2 equals 1. And then $3 direction invert mask binary, which is exactly the same. You use this same pattern here, and I had to put that on 3. So I put $2 equals 1, $3 equals 1. So then my stepper motor was going the correct direction. So Y and X, right was right, left was left. Then the second problem I ran into with my machine, Z-axis was only moving 20% of what I told it. When I told it to move 10 millimeters, it only moved 2. So I had to fix that. How you doing, Bob? Or Rob? Okay. So now, I had to go back and I had to sit and read this whole pack of paper to learn the Grbl settings to set my machine up. Alright, now the second one is to change how far an axis moves. Alright, so as I went through here, if you look right here where it says $100 right here, 101 and 102. Remember, everything in the CNC world, everything is in order, just like the alphabet. X, Y, and Z, and here they are X, Y, and Z. Okay, now these here are telling me X, step per millimeter. Okay? In other words, these three numbers, 100, 101, and 102, 100 is X, 101 is Y, and 102 is Z. And you see here, all the numbers are 800. Well, guess what? When I looked up mine said 1600, and every machine is different, depending on the lead screw, or if you're using a belt drive, or if you're using a lead screw. These will be different. But now some machines they have some lead screws and they have some belts. So your numbers might not be the same. Now on this 3018, every number should be exactly the same. But they don't have to be 800. Mine were 1600. I've seen 800 and I've seen 400. So 1600 on my machine, and on that one it said I believe it was 400. Well, 20% of 1600. It was wrong. Whatever, I can't remember the exact number, but it was wrong. And that's all I had to do was go in and change it. And I changed it to match X and Y, and my Z was it was perfect. So, and so that's the way you do it. Now, you see here on 110, 111, and 112, X, Y, Z. And here you have X maximum rate, millimeters per minute. Okay? And then you have down here 120, 121, 122, acceleration, millimeters per second, squared. Now these numbers, they might not mean anything to you. If you know anything about them, this is where you can tweak your machine. For example, $30. That means that should display your maximum RPM of your motor, your spindle motor. $31 is your minimum spindle speed, which is basically zero. And $32, that tells your machine if you're using a laser unit or not. So people have said to me, "Oh, but my laser unit, when I changed over from spindle to laser, my laser won't turn on." Okay, the first thing I had to have them do was look at $30 32. If it has 1, then it means that it's a laser unit. If it's 0, then you're using the spindle. And there's a lot of different things here. For example, if you're going to put in homing switches. Now here it says homing DIR invert mask, direction, homing feed, homing seek, homing debounce. Debounce is when, here's a switch right here. Here's a switch. And when the machine comes up and touches that switch, it's gonna make a little bit of a noise before it makes contact. It'll make just a tiny bit of noise, which you don't want. So by increasing a little bit of time there, you won't get that static noise as it touches. So it's all, these here numbers are all about tweaking your machine. A lot of people can't be bothered with them, and that's fine. I mean, I understand that totally. I mean, some people just don't want to get that far into their machine. But the way I look at it, the more you learn about your machine, the better of an operator you're going to be. Because anything that happens. Now, I'm going to give you a little example of a machine that I had a problem with, which I still have a problem with, and I think my buddy here knows who we're talking about. But we've been having a problem with a 3018 machine, and it crashed a couple times, and there was one time it crashed and it was really bad. He also has a large spindle motor, and it crashed where it went into the table, and it screwed everything up. And it ruined his lead screw right here for the Y-axis. Okay? This lead screw is what moves this table back and forth. It ruined that lead screw and the nut. So the guy had to change out the lead screw, and the lead screw that he ordered, that he got, was the wrong pitch. It was not the same thread as this. So when he put it when he put it in and got it all working and everything, we found out that the movement on the Y-axis was totally off. It was totally off. And there was no set number to put in. And what we had to do was basically he had to lay a ruler. I'm just going to, if I have my little ruler here, but I don't. But anyways, what he did was, let's just say this is a ruler, and he just laid the ruler down here, and he brought his tool right down over the 0 part of the ruler, and I told him to move it 10 millimeters. Well, I think it moved like 4 millimeters or something like that. So then we had to go into $101, which is your Y-axis movement, and we had to start changing numbers. And we would change it. We changed it to 800, and then it got closer, and then we changed it to another number, and we got closer and closer, kept trying and trying, and we had to just increase the number. And finally, when he got it, I mean, it was dead on. And then the way to test anything, if you're ever wondering if your machine is not operating correctly in one axis, in X and Y, okay? If you're thinking that, oh, well, maybe you have something's dragging in Y or something's dragging in X or something, by all means, just make a complete circle. Just make a circle in easel. Make a circle and carve it out. Carve out that circle, and then later on, measure from here. Use your calipers. Measure there to here, and then from here to here. and check from here to here and here to here. Because if your circle is going to be oblong, that means you have a problem either. Now, if you measure and that is correct, if this is exactly what you wanted, then your x-axis is off. Everything about these machines, troubleshooting, that's part of what I'm going to talk about tonight, is everything on these machines is logical. Everything is logical. Okay? So if you have, let's just say that when whoever put the machine together, that blue collar right there, which connects your lead screw to your stepper motor. A lot of people, when they installed these, they pushed that collar all the way up against the stepper motor, and it was rubbing. And after time, you get garbage underneath there, and it rubs even more, and then you start losing pulses. So it starts not moving as much as it's supposed to. Now, if it happens in X or Y, then you are not going to get 100% circle, okay? Now, another thing, for example, if you're carving and there's a straight line and you notice that maybe there's a little bit of waviness or something in the line. I mean, now I'm exaggerating it so you can just see. So, if you have any variations, this direction is your Y. Or I mean X. This direction is your Y. So, it's moving along and it doesn't hold it. That means you have a problem with your X not holding. Okay? If it was Y, then you go in the other direction and Y would show up like this. Okay? With the variations in Y. These are variations in X. So, for example, we had a problem with his machine, and I'm just trying to teach you people this stuff because it's simple logic, and that is the way you fault find on these machines. This is how you troubleshoot on these machines. Now, on the back of the machine, on the board, you have 3 plugs, X, Y, and Z. 1 plug for each stepper motor. Okay, now I had a buddy of mine there that had a problem with his, where it was grinding. He said every time I move my Z-axis up or down, or try to move it, it wouldn't move. He said I get this weird grinding sound. Okay, definitely sounds like we have a Z-axis problem. So the first thing I told him to do, power off you never do anything on the machine with wires or anything with power on. Let's get that straight right from the beginning. Never, never, never. Always power it off. And whenever you change a Grbl setting, if you do, make sure you reboot your machine or it will not take effect. Okay? It will not take effect until you reboot your machine. Now, so anyways, every time he tried to move his spindle up or down, he got a grinding noise. So I told him, power your machine off. Reach in here with your fingers and turn your lead screw by hand and see if it moves freely. And he says, yeah, it seems to be moving freely. Everything seems to be working. You know, I can move it with my fingers. There's no binds, or it doesn't feel like it's binding up or anything. I said, okay, now power it on and try it. And it said, it didn't work. All right. We made certain that at least there was no mechanical binding in there. We knew everything was loose. So, now we're going to do process of elimination. So I told him, I says, now on the back of your board you have X, Y, and Z plugs. I want you to take your X and your Z, and I want you to swap those two plugs. Okay? In other words, let me get over here just 1 second and fire this up. ESO. Just 1 second. Yeah. Okay. So, with when I told him to swap those and power it back on again, then I told him, now I want you to try the X axis. Now he plugged the Z into the X axis. So whenever he used the X jog, it should jog his spindle motor, or the spindle stepper motor. And guess what? When he jogged on X, the spindle motor went up and down. It went up and down just like there was nothing wrong with it. Then I told him, okay, now, when you jog Z, remember when you jog Z now, your X is going to move back. This is going to move here. As soon as he tried to jog Z, the X motor, this one right here, went. Okay, process of elimination. We have found out by swapping wires that there was nothing wrong with this stepper motor. There's nothing wrong with that stepper motor because it worked before too. So, it had to be the driver circuit, the Z driver circuit on his board. And that's what it was. Luckily he had a spare board. Now there are components you can change on the board. The drivers themselves, you can change them. But if you change them, I'm almost guarantee you'll have to set up your Grbl settings by hand. Okay? If you put a larger stepper motor on, that would be also, some people want to build this up a little bit and put a heavier duty stepper motor. You can do it. But you have to tune it. You have to adjust it with your Grbl settings later on. Okay? So, Grbl settings are really what's going to help you with your machine and setting it up and adjusting it and getting it correct. Now, for me, it's more used. It's used for troubleshooting and helping other people with faults on their machine. And so we talked about searching. Now, let me tell you a little bit about searching. People have asked me about searching, that they can't find what they're looking for. Okay? Let me see here. Just 1 second here. Google search. Okay, Google search. Now I have Google search up. And if you're going to search for anything, I highly recommend that you search in Google. And right here you see images. Okay? Now, right here, for example, if I click on images, and because Google search is there, look at, I get all these Google icons. But I'm going to put in here, and I'm going to put in, let's see, Manchester United. Manchester United. Here you have logos out of stadium logo. For example, if you're looking for a, look at this, huh? This is how you find things. You can find anything you want, and I mean anything. And I'm not joking. Chicken with head cut off. Watch, let's see what happens. There, chickens with their heads cut off, okay? Now, I mean, you can search and find absolutely anything you want, okay? I mean, it's, for example, myself, if I wanted to look for submarine dolphins, submarine dolphins insignia, okay? Boom, here's all, I mean, and I can scroll and scroll and scroll and scroll. I mean, I can even show more images. And I can keep scrolling. Okay? So by using Google search and using images up here, or you could put videos, but you're not going to want videos for carving. But any image you want. Let's see a maple leaf. Maple leaf. There you go. Images of maple leaves. Okay? And I can show more images. And then you have to learn how to refine maple leaf. Watch this. In black and white. Look at there. Huh? You can find anything you want. So this is your whole, I mean, and you can also look for anything. Okay? So, and here you can also look at here, types, all, photo, graphics, GIF, face, portrait, non-portrait, clip art. Clip art is a good one, because clip art is really good to use on a carving machine. There, Canada. I mean, so just refine, and if you don't find it, change your some wording. You can try black and white maple leaves, but just try different things, and you can find them. This is how you find all kind of objects, images that you want to carve or you want to burn with your laser. Okay? Hey, Brian, thanks. Nice you could make it, buddy. So, this is basically how you do all your searches. Okay? I'm going to just touch a little bit on tooling. Now, cutting tools, which, I'm sorry, but Easel calls it bits, and I do not agree with Easel. In the CNC world, the only bit, when you use bit, you say, I got a bit of dog crap on the bottom of my shoe. Or, I'm going to move my machine just a little bit. There, I just moved it a little bit, okay? Bit is not a tool, but Easel calls it that, so I'll go with it for now. Now, when it comes to tools, I'm sure a lot of you have heard me talk about them, and I mean, there's all kind of tools, okay? Cutting tools. Most people use these cutting tools right here. These are the most common ones. Let me see. There's some more here, and then now you're going to see when you're ordering tools, there's all different kind of tools. Now, these here, for example, don't waste your money buying these tools here. This little tool here is so tiny. Let me see if you can't. It's so tiny that you can actually you can't see the tool itself. It's like a hair. Okay? It goes from 0.1 millimeters to 1 millimeter. So the biggest one here is a 1 millimeter. These are basically drill bits that are used for circuit boards. Because with this machine, I can carve a circuit board out. I can carve out the lands on a circuit board. And I can drill the holes for the components. Don't waste your money getting these. You don't need them, okay? Now, these here are, let me see, these are the ball nose. These are ball nose. These are 3.175 millimeter shank. The shank, that is 1/8 of an inch. 3.175 is 1/8 of an inch. These are ball nose that you see they're rounded at the top. Okay? Then they have some that are straight end. Right here. These are flat end. These are not bald. Okay? These here. These tools here that come with the 3018 machine. Let me take one out here so I can show it to you just a second here. Just 1 second here. Okay. Well, I got 3 out, so that's good. Now, these tools here, these tiny little tools here, these are engraving tools. These are only, you see this one's actually broken off at the tip. But these are engraving tools. These are only to be used for very fine detail. Very sharp letters, very sharp lines. These are not to be used deeper than, I tell people 2 millimeters, and that's it. Don't go any deeper with these. These are not cutting tools. These are not regular cutting tools. These are engraving tools, okay? Now, then you have, here's some more flat end. And like I said, these are the most common ones used by most people. And then this set here is really a common one. They have this set and they have a silver set also. Now, if you actually feel the cutting part of these tools, it's almost like they have an abrasive on them. So they don't give you a crisp cut. But that's the way these are made, and most people use these. There's a full set of them from 1/8 of a millimeter, or 1/8 of a millimeter to 3.175, which is an or 0.8 millimeter to 3.175, which is 1/8 of an inch. Hi, Verlin. Glad you could make it. Okay, so these tools, these are the ones that everybody uses. I use them. They're fine. They work really good for short time. Okay? These tools at banggood.com, sainsmart.com, or Amazon, You can get these tools between $7 and $10 for a box. Okay? Now, with tools, let me tell you something. With tools, you get what you pay for. All right? These here being $7 to $10, that's what you get. All right? Now, I'm going to show you something else here. Now, this tool here, a lot of people say, oh, that's a spot drill. No, it's not a spot drill. This is a tiny milling bit, a milling tool. All right? Now, on the larger milling machines, you put that whole shank all the way. This is the shank here, and that's your cutting tool. Whenever you put a tool in your machine, put the whole entire shank in the collet. Okay? Because it's going to be more rigid. I mean, when you think of this, how much rigidity you have here and how much rigidity you have here, this is nothing. This tool will start wandering. These tools actually bend, believe it or not. When they're carving, they actually bend outwards a little bit because of the way they're cutting. They're cutting and it's going, the flukes are actually going into the wood and it's pulling it outward. Okay? So these actually do bend. Now, you're not going to see very much of it on wood or anything, but as a machinist, I can tell you, they do bend. Now, what I do with this tool, is I cut them in half. Cut them right in the middle with an angle grinder. That way, on my machine, you see here, I can get, basically, I put my hole as far up as I can, but I leave out enough that I have enough room to play with. And it's short. Now, there's two things that will kill a tool in a heartbeat. One thing that will kill it is chatter. If you have too high of a feed and you're feeding it too fast and you hear it's like, and you hear it bouncing and your machine is bouncing and everything, and that tool is bouncing and it's chattering, I give it about 30 seconds to a minute before it's completely dull. Okay? That's how quick chattering will kill a tool. All right? Now, another thing that will kill a tool is too little feed and a very high RPM where the tool is spinning around at 100 miles an hour and you're barely moving and you're just making a little bit of dust instead of making chips. Instead of making nice little cut chips, you get dust. Now, mind you, with those golden bits or those golden cutting tools that I showed you with abrasive, you will get a lot of dust from those. But what I'm getting at is running with a too slow of a speed, real slow, I mean really slow, and the spindle motor is winding out. You're not cutting anything. That's all you're doing is scrub. That's what we call in CNC language scrubbing. You're scrubbing the side of your tool against the wall that has already been cut. And it's just scrubbing and it's dulling it. In about 10 minutes, that tool is garbage. And you'll see it where it'll be all split up on your wood and a terrible cut. That is signs of a bad tool. Now, back to this tool here again. Remember I told you that box of assorted tools, cutting tools, you can get them for $7 to $10. This tool here costs $38. This tool probably will last, I would say, 50 times longer than those cheap tools. I do not recommend you buy one of these until you have your ducks in a row with your machine. Because if you put this tool in here and you hit start and for some reason something's wrong and it goes right over and hits your clamp, that's $38 right down the drain. Okay? So tool-wise, you get what you pay for. All right? Now there's a lot of different tools. I mean, if you're planning on doing 3D, then you're going to want something like this, a ball nose tool. You see the ball right there at the end of it? Now these tools are what they use for 3D carving. This is a kind of a little bit big one. And it's got a bigger shaft and everything. And let me see if I can find a couple. Now I'm going to show you. Now for example, plexiglass and acrylics. If you try to cut plexiglass or acrylics with one of these tools, you might as well throw it in the garbage because it ain't going to work. These tools here, when you start cutting into plexiglass or acrylics, it melts and it cakes up on the tool, and that's all it does is breaks it. Okay? So if you want to break the tool, try cutting plexiglass. Plexiglass and acrylics. Now the part on a tool that cuts is called the fluke. Okay? Now this one here is a single fluke. There's one fluke on it, one cutting edge. That's all. And it's a straight cut. There's no curl to it, no spiral to it. It is a straight cut. And a lot of people are what they ask, oh, you know about the straight cut and everything, and you have it right here. Straight cut. And then remember on easel, if you're using easel, whatever you're wondering about, if there's a question mark, put your mouse over it and it tells you right there. Straight cut bits have vertical flukes that do not pull material up or down. They are ideal for materials that split easily like plywood, bamboo, and I'm going to add acrylic and plexiglass. Okay? And they are the ones, they don't cake up. They cut really, really nice. And actually, you cut them on a pretty slow RPM, believe it or not. So, this is a single fluke. Okay? Let me see here. Now, here's another one here. Now, this is a really pronounced ball cutter. Okay? So, this is another tool. This is another expensive tool. I would say this one here is probably about $30 or so, if not more. Now here's another one, and this is about a $38, $37 tool right here. And this one, I mean, it is sharp as just touching it. I can feel that it's sharp. So anyways, just a little bit about tools, and remember, like I said, when you put them in your collet. Now I'm just gonna talk a little bit about collets, okay? Because some people I have noticed, some people are running their machine wrong. And with a CNC machine, like anything else, I'm sorry, wait a minute. Hold on for a second. I gotta set you down. Wait a minute. Just got to get this out of here so I can show it to you. Okay. All right, let's see here. Okay. This is your collet, okay? This is your collet holder. This is a nut that goes onto the machine. And your collet. Now you see what happens? If your collet is set in there correctly, it should be exactly flush with the front. Okay? And another thing, when I go like this, it does not come out. Okay? To get it out, I have to literally bend it like that. And you see how it's cocked? Well, let me see. And you see how it's cocked in there? And then what I do is I take a pencil and push it down when I have it cocked. Yeah, you have to do it with two hands. But you cock it, you bend it over, cock it, and then push it out with a pencil eraser. Okay, and it'll pop right out. You might have to work with it a couple times, but it'll pop out. Now, whenever you change tools, all these little slits in here, okay, I recommend that you take your collet out. Take it out of your machine and blow it out, because there's a taper up in here, and that taper is the same as the taper you see here. So as this is going up, it's crimping this together, it's crimping it around, grabbing your tool. Now, if you have garbage and dust in any of these little slots, here, let's say one is filled up with garbage, so all the other ones compress to tighten up your tool, and that one doesn't compress it because it's full of garbage, what's going to happen? Your tool is going to be off-center. These machines are exactly like a computer. Crap in, crap out. Accuracy in, accuracy out. It's all about accuracy. So, keep your collets clean. And once in a while, when you take your collet out, your nut, when you take it off, raise your Z-axis and take a Q-tip up in that taper up there. Take a Q-tip and clean it out. Because they need to be cleaned out once in a while. Because that sawdust will cake up in there. And remember, this lead screw, if any of you people use machines with lead screws, now I'll put a couple drops of oil on this one, a couple drops of oil on this one, not on this one. Because here all the dust is falling down, and if you have any oil on it, it sticks to it, it builds up on the nut underneath, and I mean it gets like cement hard. Okay, and I've had people say, oh, my Z-axis isn't moving anymore. Well, how long ago have you cleaned your lead screw? They checked it, and sure enough, that's what it was. How you doing, Lee? Glad to see you can make it, buddy. So, collets. Then, when you put the collet in, you have to push it. You have to literally push it until it snaps. Once it snaps and it does not fall out, that is correct. Okay? Then you can put it in. You can put your tool in and tighten it up, and you're good to go. You'll probably notice that with a collet, when you first break it loose to unloosen it, you break it loose and you can turn about one full revolution, and all of a sudden it stops again. That's totally correct. It will stop again, and you will not get your tool out until you break it the second time. That is the normal operation of a collet. Okay? So collets are important to keep clean. So now we've talked about tools, we've talked about collets, we've talked about what dulls your machine, what dulls your tools, and everything. Now, keep your machine clean. Really, keep it clean. A dirty machine is only going to give you problems, okay? Let me see, what else did I have? Oh, okay, now I'm just going to touch on a couple more things here. And remember what I said about the tools. Keep them short. The shorter they are, the less vibration you're going to get. And since I'm on the subject of vibration, all these screws you see there, and here, and here, and here, and there, all those screws, the biggest problem there is with CNC machines is the high frequency vibrations. High frequency vibrations kill. They kill, and they don't kill, they loosen up every screw. And I'm not saying if, I'm saying it's a question of when. Okay, you run that machine without having any blue Loctite on your screws. I'll guarantee you within 6 months, every screw on your machine will be loose. And this is the stuff you need to get right here. Now there's different kinds of Loctite. 243 is your thread locker blue Loctite. For God's sakes, whatever you do, do not use red Loctite on your screws. If you use red Loctite on your screws, you will never be able to get them out again unless you heat them up. And I don't think you want to start heating your machine up with a torch. Okay? And sometimes you have to take the screws out to replace something that's broken or repair or something like that. Use blue Loctite. 243 Loctite. That's LOC tight. Okay? Alright. Let me see. Clamps. This is the proper way to use a clamp. A clamp should be parallel basically with your piece of wood. It shouldn't be real high back here because it's going to be digging in with a nose here. And if it's too far down, it's going to be like this, and it's going to be pushing your material instead of clamping it down. Right here is your. Now I can move mine, and I can tighten mine up with one hand. And the reason for that is, any of you people that have a machine like this, the biggest thing is right here. What I did on this is a plastic, it's just a piece of plastic, plexiglass, thin, I think it's 1/8 of an inch, or smaller, and it fits right down in here, and it fits right in there, okay? And then this is your jack screw. This is called the jack screw. This is the one that jacks it up and down. Okay? With that plastic, it keeps it solid there. So you see I can tighten it up. And these nuts, these are 6mm screws. I bought these nuts at Lowe's. They're 1/4 inch American threads. And that's all I did was bought a 6mm tap and run the tap through them, so now they're for 6mm, and they're a lot easier to work with. But you don't want, for example, you don't want to do this because you're going to be digging that nose into your wood. And then you don't want to do this. You don't want to do this because when you tighten it up, you're going to be basically pushing your wood. It's not clamping, really. The only good clamp you're going to get is when it is basically parallel. Okay? And I usually move this back just enough where I have clearance so that it's out of the way from my work. And also, I basically barely put the nose right on it, right there. Not much at all. Like that. Okay? And so we talked about tools here, and I'm not really planning on going in on easel right today. When I did it last week. So next week I was thinking actually about talking about laser GRBL. The laser GRBL. For example, on my machine I also have a laser unit that I can put in there. Okay? And to run the laser unit, then I run laser GRBL program. Let me put it this way. Easel. Easel is a CAD CAM program. CAD-CAM, meaning computer-aided drawing, where you do the computer-aided drawing here. And then it has the computer-aided milling, CAD-CAM. This is your milling area. This is your, and let me just say something about your preview here, your 3D preview. It is an exact representation of what you are going to get. If it looks like crap, your piece of wood is going to look like crap. Okay? So, that's CAD, CAM. Computer-aided drawing, computer-aided machining. CNC machine. Computer numeric control. All the things, that everything that comes from easel is numbers, ones and zeros and that, numbers. That's what's controlling your machine. Computer numeric control. So there's a lot of definitions. I know the people that knew me back in the other group. And I really tried to teach people the correct terminology. And they did not take to it very kindly. And, I mean, that's okay. I mean, if people don't want to learn the correct terminology and want to talk like 5-year-olds, that's fine. I mean, hey. But until they went to another group where people were hot to trot. And these people went to other groups and they were basically laughed out. You know, like, hey, you know, don't come here and talk like a 5-year-old. You know, I mean, it's... People in the CNC world take terminology very seriously. Okay? I mean, just to give you an example, what we talked about earlier, Grbl Settings. Then you have a program called Laser Grbl. And I had people telling me, well, I've been running Grbl. And I'd say, what? You're running Grbl? Well, that's something new. You got to teach me how to do it. Because I don't know how to run Grbl. I mean, I can run Laser Grbl, and I can use Grbl settings, but I've never run Grbl. So, just to show you, there's a big difference between words in the CNC language. And another thing I touch on every time I do a live session, or I talk to anybody, if I do a one-on-one, one thing I really try to pound into people's heads are use millimeters, use the metric system. The reason for that. You see here, the star, okay? Now I can go in here, if I highlight this, I can go in here and I can go over here and I can see that this is basically 50, and if you look really close down here, you could actually see it's stippled. Okay? You can't see it on here, but you can kind of see it over here. But anyways, this is basically 53 millimeters wide. And it's basically 53 millimeters high. Okay, now watch this. Now, this is 2-point watt. Okay? This is about as accurate as... It's just not accurate. Okay? Please. And I tell people, and it's true, CNC machines were developed around the metric system. CNC machines do not play well together with inches. Okay? And learn to use millimeters. Do not try to convert in your head. Oh, well, I can tell you that 10 millimeters is equal to 1 centimeter. Okay? On some rulers, you'll see 10 little marks, and then you'll see a 1 instead of a 10. Because it's showing centimeters instead of millimeters. But the millimeters will still be there. Everything is a base of 10. Very, very simple. You can't get any simpler. And then also, when you talk about metric system, it's everything. Water. 1 liter of water weighs 1 kilo. How smart is that? How much does a gallon weigh, And whoever came up with water freezes at 32 degrees and boils at 212. Well, isn't it a lot easier to remember water freezes at 0 and boils at 100? So metric system is cool. Very, very much better. It's much, much better to use in the CNC world than inches. Okay? So basically, I've kind of touched on everything. Any of you people have you got any questions or anything? I'm open for some questions. Now, I can't guarantee I can answer them, but I can try. But, and this is an upgraded motor, and this is a bracket I made, and this is a bracket that I broke. There was lips on here where you tightened it up, and I broke it. I have a brand new bracket that I printed out on 3D printer. And if you people want to do a session on 3D printing, I'll be glad to do it. Okay? 3D printing, it's coming in fast. So this is the new one, and these are the brackets I broke off. This here was printed in multicolored satin metallic. So this is found on Thingiver's. Anybody that has a 3D printer, go to thinggivers.com and you can find basically anything. Somebody had done this upgrade before, and they took and designed that bracket. So I found it on Thinggivers because this motor, it's a 55 millimeter motor, and the old one is a 45 millimeter motor. The old motor on the standard motor that came on this machine, retail for the motor is $4. So it tells a little bit about it. It tells a little bit about the quality of the motors that come on these machines. All of these machines, no matter who sells them, they're all made in the same company, the same factory in China. One factory makes them all. The 3018s. Another factory makes the 6550s. The only difference is you have 100 different salesmen. And some salesmen like to gouge. So be careful. Always, always search. Compare prices. And when people are asking me, well, Paul, what do you suggest as far as the next machine, a bigger machine? This is a hobby machine. This is a toy. This is a machine to have in your house to make little things and, little gifts and stuff like that. It is not an industrial machine, and you can't run it as such. Okay? Now, when people ask me about bigger machines, I can't tell you what is the best machine, because some people like Shapeoko, some people like Xcarve, and some people like, there's different ones. There's a bunch of them out there. The biggest thing, read reviews. Google them. Google, just type right in 3018 reviews. Shapeoko. Just type in Shapeoko CNC machine reviews. Let's, just for the heck of it, let's just try it and see. Let's just see what comes up here. 1 second here. All right. Okay, and then here I go to Google search. Okay, and then my Google search bar comes up, and I put in, I'm going to put shape, okay. There it comes up, CNC router. Okay, now I can say CNC router reviews. Okay, let's see. There we go. Size for your workshop. Okay, here. High performance CNC router, heavy duty, precise reviews. CNC router reviews. We have it on our website. Shapeco CNC router reviews, videos, results. Shapeco 3XXL reviews. Choice, Editor's Choice 2020. Okay? Anything that I buy when it comes to CNC machines or anything like that, anything. You want to buy a weed whacker. Type in, go in, search reviews. Use the internet. Okay, let me see here. Let me see it. Donald, I don't really bring them on camera. What do you mean, man? Fred said they are tough motors, no joke. Paul is correct. Correct on the motor. These motors here, they will change your life. Really, I mean, running that machine with that motor is like night and day compared to what it was. Okay, and that's all I did was I searched 3018 and larger spindle motors, and I found a bunch of different things, and that's when I went with $68 for the motor, the power supply, and the potentiometer. And I have full control of RPMs while I'm carving. Okay? In the laser world, will you ever talk about the settings on the laser GRBL and what each... Yes, I will. Yes, I will, Bo. Next week, Monday next week, I will be doing laser GRBL. How about that? Okay? So, yes, I will be doing laser GRBL. Oh, anyways, that's basically all I had tonight, and we've went pretty quick tonight. If you want, I can talk a little bit about 3D printing. If you want, I can show you what it looks like. And this is what the inside here looks like. And let me see here. I got stuff all over here. Let me see here. So I go to utilities, and I go to jog mode, and I want to jog my Z-axis. Okay. And then I want to go there, and I want to go okay. Oh, why do I keep hitting OK on that? There. And strange. It only wants to do it once. I'm going to bring my table forward. That's the way it's supposed to work every time you hit it. So this is how big of an area I have to work with. That is the whole area right there. I believe it's 6 by 6 by 6. And let me just see if that Z-axis will work again. That's weird. Weird. Let's see, I'll check out why that doesn't work. But my printer has always given me really, really good results. I mean, here's some of the stuff, you know, just, I do silver work, so I needed ring sizers. So here's all my ring sizers, both male and female. And I mean, this is just some stuff that I made, I designed, I printed out. It's just playing around with it, but I mean, just to show you some accuracy, this is a part that my cousin designed on a CAD CAM program. One of the real expensive ones. I can't remember the name right now. But anyways, he designed that and I printed it out. It's accurate within 0.001 of a millimeter. Okay? And here's toys that I made, which is a gimbal. Here's a house that I built or that I printed out for the a train set, HO train set. So I mean, there's a lot of stuff you can do with a 3D printer. That's pretty darn cool. And I'll be going into that. Probably week after next. But like I said, next week I'm going to cover laser GRBL. And let me see here. I have that right here. Laser GRBL. There we go. Here we go. New version. Now, we suggest update the current version. Okay. I'm not going to do it just yet. I'll do it later on, and I'll do that later on. But this is Laser GRBL, and this is what we're going to cover next week. And there's a lot of cool tips I can give you on this one to get a nice burn. So, with that being said, I think I have pretty much covered everything that I was going to cover tonight. So, I mean, if you guys have any questions about what I covered or anything, do me a favor and shoot me a message. I have most of you guys I have use on Messenger, so it's just hit me up. I'm retired, so I have all the time in the world. And if any of you people want a one-on-one, even if you want a brush up of what we've gone through before, hey, hit me up. I'll do an hour or two with you. And if it takes more, I'll do that. So whatever, I'm here, in my group, I'm here to help you people. All right? And if you have problems with your machine, don't hesitate to hit me up. I can help you. If I can, I'll help you with it. Okay? This is what I enjoy doing. I mean, this has been half of my life. So when it comes to CNC, I can teach you that. And another thing, if you want to learn G-code, I used to be able to sit down and write a G-code program just like writing a letter. Okay, I can take a G-code program and read it as I'm going down, I visualize in my head what that tool is doing. And it's pretty cool when you get to that point where you know what the different codes are. And there's not that many, really. There's probably about 6 codes that you need to know when it comes to G codes, as far as movements and spindle and all that. It's not much. And it's very simple. It's not magic, it's not hocus pocus, nothing like that. It's pretty simple, and it's interesting actually, because if you have a problem, you can actually go in and look at your G code and look, is it a machine problem, or is it a G code problem, or am I telling that tool to go down into the table, or is it doing it by itself? So there's a lot you can learn from G code. This is, let me see here. I was just going to show you. I just have a little pocket G code here. And G00 at the top, positioning, rapid, transverse. That's rapid feed. G1 is linear feed, regular feed. And whenever you use G01, you got to use F, which is your feed, a number. Okay, G02, circular interpolation. Now, that means if you're going to cut a circle, it will go in a clockwise direction, and G03 will go in a counterclockwise direction. And if you people ever want to learn these, I can teach you, and I can teach you how to program it. It's pretty cool, actually. But anybody that is really interested in getting into CNC, that's the heart of it right there. Okay? So, with that being said, I'll say I'm finished tonight. And I really thank all of you people for coming out and joining me here. I hope you got something out of it. I try to throw a little bit of tidbits of everything in here. And the only thing I'd like to tell you people is to be safe, be careful. There's a lot of shit going on today, man, that I'm sure you all have noticed on Facebook, and I'm not even going to go into it, okay? Let's keep it fun. Let's keep it CNC and carving, engraving, laser burning, 3D. Okay, so anyways, with that, I'm going to sign off and thank you all again. And I'll see you guys next Monday for Laser GRBL. Okay? We'll see you. Bye. Have a good evening. And this, by the way, this video will be in the group. And you can find my video from last week. If you go, instead of searching all through the group to find it, go up at the top of the group. You'll see there's tabs up there with announcements, photos, la-di-da. But anyways, it's in photos. Go into photos and you will find my video from last week. Okay? You guys have a good one. Nice seeing you tonight. I'm hoping to see you next week. And I hope you guys are finding some kind of interest in my group. And if you're not, let me know. Let me know. We're trying to make it as good as possible. And I'm still working on 3D printer prices. Let me tell you what. Especially since this coronavirus thing, things have gone to a halt. It really has. And I don't know if you people are in that in the other group, Arduino programming group. But anyways, that's another thing that we've started doing in our group is programming. I can just show you. I can show you real quick what I'm talking about. And now this is really cool. And really it gives you can build your own 3D, your own CNC machine. So basically this is all circuitry, circuits. This is a circuit board. Basically, this will run a 3D printer or a 3D CNC machine. And you build circuits with a display and stuff. So this is what I do on the side. So, and here's a, let me see here. Here's a breadboard, and you have everything. You have waveforms, coarse frequency, frequency adjustment, amplitude, DC offset. You have for resistors, 1K, 100K, and you have power supplies, and you have all kind of your data switches. Okay, and you have your logic indicators. I mean, there's a lot of stuff. And this is another one, basically another type of circuit board. And you have power supplies, but this is kind of stuff I get into. This is the part of Paul's group, digital gadgets and cool digital gadgets. This stuff, and it's a lot of fun. And I mean, if you want to get into that, that is in our group, and you can order a starter kit for like $25, and the instructions are online for free. So if you want to learn how to program an Arduino board using code, you can do it. Okay? All right. With that, I'm going to sign off, and I hope you guys have a good one, and I've enjoyed it. And I'll be looking forward to next week doing laser GRBL. Okay? And we'll see you guys next week. Bye.